Hey guys, welcome to your 4.6 notes on formalizing relations and functions. By the end of the day, you will be able to do 3 things. First, determine whether a relation is a function. After that, you'll find domain and range. And then you'll be able to use function notation. So when we talk about functions, remember that a function is basically a rule. And in a function rule, you take an input, and your input is usually your x values, or we call that your domain. And your input is what you put into your function. So if you have this little guy right here, and you take your input values, you plug them through this kind of like rule of a box of some sort, right? And then at the very end, you'll spit out your output. Your output comes out of the function rule. And your output is going to be your y values. Now, we also call the input values, we call that your domain. And then your output values, we call that your range. So did I use all my key rules, my keywords? Function, input, output, range, x values, y values. Excellent. Okay, so let's jump into some definitions. A relation is a way to pair numbers together. It's basically a relationship, right? It's a pairing of numbers in one set, which is the domain, with another set called the range. So we're going to connect the domain and the range. The domain is all the inputs, all the x values, and the range is all the outputs, all the y values. A function is a special kind of relation in which you have each member of the domain only goes to one item in the range. So you can't have like a split of 2, they each go to one thing. Exactly one value in the range. What this looks like in pictures is, let's say we have this function. We're going to map all of our domains. We're going to map all of our inputs. We're going to map the domain to the range. Okay, so we have all of our domains as -2, 0, 4, and 5. So we have -2, 0, 4, and 5. That is our that's our domain. I'm going to put it in a circle, like that. Okay, great. And then our range is all of our y's. So if I were to write them from smallest to biggest, that would be 0.5, 2.5, and 6.5. Awesome. So here we have our range. Now the mapping is when we connect what's in our domain to our range. So -2 connects with 0.5, 0 connects with 2.5, 4 connects with 6.5, and 5, circles back and goes to 2.5. And that's fine. This is a function because each x only goes to one y. However, when we look at B, we're going to do the same thing. We're going to take our domain, we're going to map it to our range, and hopefully we won't get any repeats. So let's put all of our domains over here from smallest to biggest. We have -4.2, 5, and 7 represented. Cool. And then in our range from smallest to biggest, we've got 0, 1.5, 2.2, and 4.8. Now this time we see that -4 goes to 1.5, 5 goes to 2.2, 7 goes to 4.8, and -4.2 also goes to 0. Since we have a member of our domain, we have an x that goes to 2 places in our range. Yikes. That's not okay. That tells us that this is not a function. So each x should only go to one y. It's okay that y is covered by 2 x's, that's fine, but you can't have 2 x's. You can't have one x that has 2 different y's to it. this is one way to visualize. So this is called a mapping diagram. That's one way to visualize a function. I have a better way that I prefer. You know what, if you like mapping diagrams, all the power to you. But I prefer something called the vertical line test. This is your key idea of the day. You love the vertical line test. The vertical line test will tell you if something's a function. And here is the vertical line test right here. If you draw a vertical line and it passes through more than one point on the graph, the relation is not a function. Okay, that's words, but what does that look like in pictures? Look, I have two functions graphed for you. This function is, or sorry, not two functions. I have two relations for you. This relation is a set of points. So let's draw a vertical line and let's see if it passes through more than one point anywhere. So if we start here and go, oh, here it passes through 1 point. At x equals 1, it just passes through 1 point. At x equals 0, it passes through 1 point right here. Let's keep going. We keep scanning, 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 beep. Oh, but here, blah, we got 2. We got 2 points. Oh no. So what this is telling us is this says when x equals -4, y equals -1, and y equals 2. We can't have that in a function. We can't put one input out. Sorry, we can't put one input in and get two different outputs. That's not how rules work. That's not okay. So this tells us that this is not a function. Okay, well, look at this one. Y equals -x squared plus 3. Let's draw another vertical line test. Sorry, a vertical line and perform the vertical line test. We'll perform it like a scanner. So, boing! Oh, you know, here we just have 1 point. It only intersects right there at that 1 point. Okay, cool. Let's keep going. And still, no matter where we go, it only ever intersects at 1 point. Cool. So because it only intersects at 1 point, this is a function. Also, a good rule is you can see that it's got its equation, right? And that's fine. You'll notice, actually, let's do a horizontal line test to show you why the horizontal line test doesn't work. Here, there are two values. There are two x values that will give you a y value of 2. So when x equals 1, y equals 2, but also when x equals -1, y equals 2. And that's totally fine. You're allowed to have two different x's going to the same y's, but you cannot do the opposite way. Alrighty? Alrighty. When we look at this rule, this is written as an equation, and that's fine. It says, hey, you know what? Whatever x is, y is going to be that. But we can come up with a new name for y. We can say, because this is a function, we say this is a function of x. And we say, all right, well, no matter what we plug in for x, that's the value of that function. So the value of that function there is, so the value of this function at, say, 0 is 3. Cool. So we say the value of the function at 0 is 3. So the function of 0 is 3. What about at 1? The value of the function at 1 is 2. Okay, cool. Let's do another one. The value of the function at 2 is -1. So all we're doing, instead of saying, well, when x equals 3, when x equals 0, y equals 3. But we're saying that in less words. So this is when x equals 0, y equals 3. When x equals 1, y equals 2. Oh, that's so much to write. Instead, we just say, you know what? The function at 0 is 3. The function at 1 is 2. The function at 2 is -1. So this guy right here, he is called function notation. So we can say this is a function, and the function rule is this guy right here, whatever y equals. X squared plus 3, but just kidding, it's -x squared plus 3. Yay. fact, we should kind of write it like this. I missed. So f of x is the same thing as y. Okay. Oh, and we call it f of x. So it's not saying that f is a variable, because f is not a variable. It's just like the name of the function. Because when things get more complicated, you'll have different functions going on. You'll have different y values happening. So you can say this is f of x, g of x, w of x. You can take my word for it. Knowing that the function w of x equals 250x represents the number of words you can read in x minutes. So if you read for 1 minute, you can read 250 words. If you read for 0 minutes, you read 250 times 0, which is 0 words. Great. So how many words can you read in 6 minutes? Well, since 6 minutes is representing our time, we're going to plug that in for our x. So we say, oh, not f, sorry. The words you can read in 6 minutes equals 250 times 6. We took our function and we plugged in 6 wherever we had an x. Excellent. But yeah, okay, excellent. And now we're going to solve it by simplifying 250 times 6, which is 100. Sorry, not 100. 1,500. So what does this mean? This means that I can read 250, no, just kidding. I can read 1,500 words in 6 minutes. You don't have to divide by W once you get here. This is a very common error. Pay attention right now. This is a very common error. You don't have to divide by W once you get here. Just that is the answer. The words you can read in 6 minutes is 1,500. Okay? Cool. Now remember what the range is. The range is a collection of all the y's. It's the outputs of a function. Here, technically, we don't have any y's. We have g of x's. But g of x is the same thing as a y. All of our g of x's, that's going to be our range. So how do we find the range of a function? Well, we plug our domain in for x. Because the domain, remember, is your input. So that's what we're going to put in to the function. The easiest way to do that is to create a table. You'll put all of your x's, and that'll spit out your range, your g of x's. And then in the middle, I like to put whatever the rule was. Here we see that g of x equals 4x minus 12. So I plug that in there, 4x minus 12 in the middle. Then we take what's in our range and we put them in, we take what's in our domain and we'll put them right here. So we've got -1, 0, 3, and 8. Now that we know what our domain is, we'll take all of our x values and we'll plug them in here. So we'll have 4 times our x value minus 12. So since x is -1, we have 4 times -1, which is -4, minus 12, which is -16. We'll repeat that same process for each of our x's. So 4 times 0 minus 12 is -12. 4 times 3 minus 12 is 0. And 4 times 8 minus 12 is 20. So now we have our range. Ta-da! Okay. Now, how you write your answer is you put the range in set notation. Remember, set notation is you put these curly braces here. I am never going to judge you on the quality of your curly braces. Just give me your best shot. It's -16, -12, 0, and 20. And there you have it. Ta-da! Even a professional answer would be to take this and say, hey, this is g of x. Done! And you got it. Cool. That's great, Ms. Van Dyke, but when are we going to use this in real life? Well, let's say you don't want to do the same math over and over and over again, because that would just be total garbage. So instead, you need to come up with a rule. You need to come up with a function And then you can just keep plugging in different inputs. So here you've got your situation. A landfill already contains 600 tons of garbage. Gross. Each week, 35 tons are sent to the landfill. Oh, hey, week. Time is always an independent variable. So we've got 35 tons are sent to the landfill. Write a rule that expresses the tonnage. The tonnage of garbage, G, is a function of time, T. Now this phrasing was super nice because it told you which variable was which. As a function of means that this, so if we see as a function of, whatever follows that, whatever is the object of your prepositional phrase of something, that's going to be your independent variable. So next time you're sitting in English class, and you're like, when are we going to ever use this grammar in real life? You just did. Nah. Okay. And then representing what is our other variable? Tonnage of garbage. That must be our dependent variable. We love it. So that tells us that G is going to be equal to something about time. Okay, what do we know? Well, each week, 35 tons are sent to the landfill. So that's going to give us a times 35. 35 times however many weeks we have. So after 1 week, we've got 35 tons. After 2 weeks, that's 70 tons. Except we already have 600 tons. So we'll just add 600 on there real quick. Hey, we got it. That's our rule. G equals 35T plus 600. And now you can figure out how much garbage you have with any number of weeks. Let's just do 8 and then call it a day. Since 8 weeks is a function of time, we're going to take 8, plug it in for time. So 35 times 8, which is 280, plus 600 equals 880 tons. Oof, that is a ton. It's actually considerably more than a ton. But there you have it. That is how to determine whether a relation is a function. Use the vertical line test. But also be able to explain why you just need you need one output per input. You cannot have one input going to 2 different outputs. That's not okay. Be able to tell me that the domain is all the inputs or the x's. The range is all the outputs or the y's. And finally, please remember that function notation is a name. And in this case, if we have 3 different functions, f of x, g of x, h of x, these guys are not variables. These are the names of the function. There you go. Quick review. Yeah, I don't even have a pun. Oh, hey, yeah. So on your homework, I hope you put the fun in function. Have a great time.